Okay, so here we have a problem. We're going to start with number 6. And it says, what is the value of f prime of a, or the derivative at a, when a comma f of a is the top of a mountain or the bottom of a valley on the graph of f of x? So when it says the top of a mountain, that means that you're going from increasing and you're changing to decreasing. So the top of the mountain would be at this point right here. So for example, if we were to draw like a little function, then this would be a, and this would be f of a. And so when you have a point that is on the top of the mountain, that means that the derivative, if we are to sketch the tangent line would be a horizontal line, or that means that the slope of that line would be equal to 0. So at the top of a mountain, f prime of a would be equal to 0. And the same thing would happen when you're at the bottom of a valley. So at the bottom of a valley, you change from decreasing to increasing. So at this point, x is a and the y is f of a. At this point, again, we have I didn't do that very well, but a horizontal tangent line. And that's where the slope of that tangent line would be equal to 0. Okay, so that's number 6. And then for number 7, there was a question about 7 as well. It says when f prime of a is positive, or the derivative at a is positive, what does this tell you about the instantaneous slope at f of a? Well, f prime of a, the derivative is the instantaneous slope. That is, that's kind of the definition of the derivative, is the instantaneous slope. So if f prime of a is positive, then you know that the instantaneous slope at f of a is also positive. So for example, if you had some function at a, you know that the function would be increasing because that slope would be positive. And when the derivative is positive, the function is increasing. And similarly, if f prime of a is negative for problem 8, if f prime of a is negative, that tells us that the instantaneous slope at f of a would be decreasing. Or excuse me, that the instantaneous slope would be negative because the function, if the derivative is negative, the function is decreasing. So I hope that was helpful. If you have any questions, please feel free to let me know in the comments. And yeah, or also if you have any other questions, let me know.